All right there. Hi, everybody. How are you doing today? Hope you're having a great Global Hack Week so far. And thank you so much for joining for this stream about cracking the technical interview, something a lot of people are interested in, especially if you're looking for a job in the tech field. This is a great place to get some experience just handling those types of problems and thinking about the approaches you might take. So welcome everybody. If you're there, please give us a little chat. It's something we love to see. Just how's everybody doing? And get some feedback. So yeah, that would be awesome. But let me pull up our slides for the day. Cracking the technical interview. In the meantime, Henry from Pasha. Hi there. Good to meet you. And Marissa Ponce, who says sleepy but ready. Love to hear it. So we'll try to keep this not too boring then. But first, before we begin, even at all, it's really important that we check in. And I'm even going to send a link in the chat so that you all can check in too. Because it's so important to check in for these events. It tells us what kinds of things you all are interested in seeing for Global Hack Week. It tells us really, are we hitting the mark? And also it gives you some benefits too, because it gets you points for the week to be checking in, to be participating, and in general, just getting those swags depends on it. But yeah, hi there, everybody. Wow, 4 a.m. That's really early. Yeah, it's so great to see people from all over the world coming in for Global Hack Week. But just remember too, a lot of these are streamed and also recorded free of charge. So if you ever want to check a recording on the other end, that's totally okay. But yeah, hey there, Monsterm. Good to see you. Well, okay. Why don't we remember to check in? I've pasted the link. I'm going to paste it one more time just for good measure, and then we'll move on. So I just want to start with a quick intro and agenda. So welcome, everybody. Welcome to F. Francie as well. I'm Stephen from MLH, and yeah, I've been working with hackers as part of the MLH community for more than 6 years now. And I've worked as a technical interviewer for the MLH Fellowship Admissions Department. In fact, I still work as a technical interviewer for that department. And I'll talk a little more about our fellowship program as well today, because I get a question about it all the time. And it's really relevant to our topic today, which is how to crack the technical interview. So we're going to talk a little more about that as well. But here it is. So the fellowship program is at our website, https fellowship.mlh.io. I'm going to put that in the chat actually, just in case anyone's interested in our fellowship program, because it can be a great experience for people who are interested in learning software engineering through open source projects. That's what the tagline says. And in fact, it is a fully remote program which gives a 12-week stipend. That stipend is mainly for your living expenses. So it's a little bit different than an internship where you would be getting a salary. It might be lower than that to just cover your living expenses. But it's a great experience. You'll meet people from all over the world who are passionate about technology and wanting to really get into deeper diving into software engineering and the community. And this spring 2025, we'll be having another program. It'll start January 27th, 2025. And the deadline for applicants from APAC, which is applicants from the Asia region predominantly, is the 30th of November, which is coming up. It's only 22 days from now. And the deadline for applicants from other regions is December 31st, which is still not as far away as you might be thinking. So yeah, definitely apply if you are interested in this opportunity. And if you have any questions, I'm happy to answer them here, or even through some email. But yeah, why don't we go ahead and answer some questions, because I actually have a few questions I can see in the chat about the fellowship. So the first one is from Racosaurus. I went to a community college. What can I do to be competitive and stand out? And honestly, Racosaurus, I want to tell you, in our programs, I'll let you in on a secret. We do not really give you a big boost depending on which university you graduate from. We are mostly concerned with your skills and also your attitude towards learning, towards the passion for the community. So, whichever, college, that's great to go to a community college, get some experience with with tech. It might be good to take some classes in tech. I would recommend taking some computer science classes while you're in community college, if they do offer them there. And if they don't, take some mathematics classes, take some math classes, some IT classes. And yeah, that would be great. Um, and then let's see, Pasha, and is it possible for a newbie to get into this fellowship? It is totally possible, but I would say it's not as likely, to be totally honest with you. And the reason for that is because the fellowship tends to be people who have a solid foundation in programming. And that's because we want to take you from having a solid foundation to that next level where you are doing professional level software development, which is actually much more difficult than building a project on your own, because you need to also consider other people and make something that is going to be lasting for the test of time, integrated with other projects, integrated with other teams. So that's why you need to use lots of professional best practices that you might not know if you are just a newbie. So definitely try to build some of your own projects first, get the hang of it. And that's what my advice would be. But I also think it's totally cool to apply. It's actually free to apply. So I always say apply, why not? And you may surprise yourself. And Al Quatra says, good to be part of the session. It's awesome. And yeah, my current Twitch username, good resume, good portfolio. Sorry, excuse me. Good LinkedIn, good GitHub, good networking. They can all be really good things to have for getting any kind of position. So that's great. And I'm planning to apply for the fellowship. I'm in CA. I'm assuming that means California, but it could also mean Canada. So, but either way, the advice will be similar. I applied last time, but was not selected. I'm preparing to apply again this December. I'm a master's student doing CS. I am particularly comfortable with ML, DL, and Python. Any tips for getting through this time? I really need this. So thanks for that question. If in your comment, you mentioned that you're particularly comfortable with ML, DL, and Python. And so what I would recommend is, when you are asked to submit a code sample, submit your best possible work in ML and Python and DL, because you will want to demonstrate your most proficient focus area. We want to see what are you best at, and if we can tell that, it'll make a much better case. Sometimes people will submit a code sample that is really, it's something that really might just be a class project that they did. um, you know it could be like something they did in their CS class that was really, not a very big project, maybe just a few files and something their professor asked them to do. Really simple thing. And we'll evaluate that. But in reality, their code samples in their GitHub are just so good. They might have some amazing projects that they've done all by themselves or with help of a team that they've assembled to build something really original and really technically impressive. And I'm always thinking to myself, like, why didn't you submit this for your code sample? And we do try to actually look around and try and find a lot of your work, whatever you do submit, whether it's your LinkedIn, your GitHub. But honestly, the code sample is so focused in not just our interview process, but many people's interview process when they're involving with the code sample. So I highly recommend to put your best foot forward for that code sample. And if you're confused on what kind of projects you're to work on with regards to that, I would try to do something where you are, learning from scratch on some of these algorithms, because it's one thing to just implement those, in the way that they've been coded up already by somebody else in a library. But if you can modify a machine learning algorithm to your specific use case and code that from scratch or from some base components, that can be just so cool. And yeah, just coming up with something that you can do, from the ground up would be my advice. And Dexel says, I applied to the fellowship one time before, but I didn't get to the interviewing phase. And I think it was because of the code I applied with. Can you tell us about how the perfect project looks like to apply with? I guess I mentioned this a little bit, but what I would say is there is no one perfect project. The perfect project is one that's going to showcase your most advanced skills possible, and preferably in a field that you're interested in working in. So, for example, don't submit some cryptography project if you're really more interested in machine learning, because that will be telling us that maybe you're really strong in cryptography, but we're not sure how strong you might be in machine learning. So that could be really different. And all right, yeah, no problem, Pasha and other people. Thank you for those questions. And oh, yes, it's totally accepted, Alquatra, that you can do MLDL projects. And one last question I noticed from Real DEX Boy. I'm currently doing a job which is not really technical as an instructional designer. I'm planning to do a job change. How do I proceed? And I have 1 year experience. So again, I think if you are in this position, actually tech is a great field in a lot of ways because it's very, meritocratic. And what I mean by that is that there are aspects to getting a tech job which are solely based on how well you can perform at some exam. And the technical interview is one of them. So study these exam questions, the ones we're going to go through here, and the way of thinking. And if you can perform well at that, then you have a good chance to get a job in tech. It's not as much about what did you study before, who was your advisors, what was their name at university, what kind of GPA did you get? I mean, these are important things in any job, but I do think tech tends to enforce a little bit more of this, emphasize more of this meritocratic process. So with that, why don't we get moving on? Because I do want to cover some of the goals for today. My main goal is actually to give you more confidence when you go for a technical interview so that you can see and recognize what are the things we should be doing for a technical interview, and develop some key skills and strategies towards that end. So, we're also going to understand what interviewers look for and really try to practice some of these coding problems together. And so that's going to be really a great experience. Just have a quick agenda overview here of all that. We'll start by understanding technical interviews, then mastering coding challenges. Then we'll go into some coding best practices and some live problem solving where we'll actually see some live coding and I'll ask you to follow along too. We'll have some behavioral questions and some soft skills because those are often a part of the interview, and some mock technical interviews too. So I'm going to show an example of a mock technical interview and ask you to tell me what went good and what did not. Okay. And some common mistakes and how to avoid them. And then finally, some tips and resources for you as you go forward and improve your technical interview skills. So, first, we'll talk a little bit about what is a technical interview. And essentially, there's a lot of misconception, really, that technical interviews are just like a test of your coding knowledge. And, the more coding you know, the better you'll do in the technical interview. While that's true to a point, they also serve to evaluate your communication skills and how you solve a problem. And those two things are really important for working on engineering teams. And in some cases, even more important than being able to code, because you could be a great coder, but if nobody's going to know about your work and you're not going to be able to communicate what you're doing, you might as well just not even know Python at all, right? So, yeah, it could be really important. And a technical interview is a crucial step for many technical positions that, as it says here, usually is occurring after the initial screening process. So that's like your educational background, your work experience, things like that. Once they see that you have those requisite baselines, they might invite you for a technical interview. And it's designed to assess not just your coding knowledge, but also your problem solving and your communication. So now I'll talk a little bit about what do interviewers look for. They look for more than just you getting the right answer to the problem. A lot of people think, oh, if I get the right answer to the problem, then they'll hire me. But they are actually looking at how you approach the problem, how you communicate about it, and how that might fit within their team. So let's just take some of those things. How you approach the problem is a little bit about your problem solving abilities, this first point here. And then communicating your thoughts is your communication skills, that number 3 point. And then fitting within the team is that last point, cultural fit and teamwork. For example, when you're stuck on a problem and you're not sure how to go forward, are you going to tell the other people on the team? Or are you going to be too embarrassed to tell them that you're stuck? That could be a really big deal breaker for some teams. And so that's going to be what they're looking for in this interview. All right. So there are actually many types of interviews, of technical interviews. So just to name a few of them, there's algorithms and data structures interviews where you're going to do some write this algorithm, tell me how fast this algorithm runs in the worst case scenario. Improve this code. What is this data structure? Why would you use it over something else? Then there's system design, and so This could be anything from, let's say we have a problem we're trying to solve. How would you build the system to be optimal for this problem? There could be coding assessment, which was what we're going to focus on today. There could be whiteboard sessions, which they ask you to sketch out your plan on a whiteboard in pseudocode instead of real code. And then some pair programming could even be happening, just to simulate that work environment. And so here's some examples of interview processes that I've put up here. Let's just say company one is really emphasizing problem solving and algorithms. So they might actually have a process where they have multiple rounds of whiteboard coding, where they're not even asking you to write real code. They're just saying, walk me through this problem. Here's a challenging algorithm. Walk me through it. And then company two might focus on their leadership principles a little bit more. So maybe this job is more of a leadership role. So they might actually have a mixture of these behavioral questions and some of those technical questions that we might ask that might be relevant to the field. And then let's say there's some company three, which might combine coding with some system design questions. Maybe they have a very specific scenario that they're interested in addressing, and they might give you a scenario and ask you for some input on that. So that is really going to test your architectural thinking as well as your coding. But yeah, so there's many ways to get at an interview, and you just have to kind of be prepared for it to go in a number of different ways. Usually the company will tell you which of these three, will happen. And it's your responsibility to make sure when they say a technical interview, what do you mean by that? What do you want me to be doing? All right. So now we're going to be doing a little bit of mastering some coding challenges in this presentation, in this workshop. But we are going to have to develop a problem-solving approach, because when we get a problem, remember what I said before, it's not just about getting the right answer. In fact, that's sort of germane to the process. What they want to know is, how did you get there? So what we do is we follow the PREP method. And PREP is an algorithm, just not an algorithm, excuse me, an acronym. I guess it's also kind of an algorithm. But it's a great acronym to remember how you should respond to a question in a technical interview. So the first P in PREP stands for problem understanding. And it's like making sure that you fully understand the problem, and you could restate that in your own words if you needed to. And then requirements clarification is really important. So this is asking questions to clarify if there's any ambiguity in the instructions, or asking, hey, what's the constraints on this? How much time do I have? How much do I have a GPU? Do I have access to a GPU, a supercomputer? That's going to change my answer. And then this third one here is examples and test cases. So you're going to walk through examples to see how the problem works, maybe identify some edge cases if there is some edge case, and handle that. And then finally, pseudocode and implementation. So this is where you would actually outline your solution in some pseudocode before you write actual code. And then, of course, you could be asked to write actual code. But this is a great way to organize your thoughts, is by using this PREP method. And then we also want to communicate our thought process during this whole thing. So we want to be thinking aloud, so that the interviewer can follow your thought process. And then, don't hesitate to ask any clarifying questions if something is not clear to you. And definitely, discuss if there's any potential solution before you jump into coding because, you could say, okay, well, I'm leaning towards doing this, but I've also thought about this approach and this approach, but I'm leaning towards doing this, and here's why. So that's a really, really useful thing to do because you want to show that you're deliberate in your thinking and strategic and not just going for whatever comes to mind immediately as the solution to the problem. Some people might be able to do that actually, but I certainly cannot. And so, all right, now I want you all to actually choose a coding problem for us to do first. So if you want to choose one of these, just send a message in the chat of which one we should do first. It could be A, which is reverse a string. It could be B, which is find the maximum number in an array. And it could be C, which is check for palindrome. So one vote for B, one vote for C. I think I'm gonna go with it because and then a vote for A, a vote for B, C, and a A. All right. Well, since there's one vote for everyone, all right. Hal Quattro says B as well. So maybe we'll go for B first. All right. So B, let's try first. I think we need slide number, let's see, slide 17 perhaps. Oh, that's the solution to one of the other ones. Okay. Pretend you didn't see that, everybody. We'll try B because we had the first person say B, so why don't we just do that one? And we are going to do all of them. Yes, Super Yoda one. I just thought it would be fun for us to pick which one to do first. So we'll find the maximum number. And so this problem is starting with a description. So write a function to find the maximum number in a list of integers. Okay, and so they gave an example of how to do this. And so the example gives 5 items, 3, 1, 4, 2, 5. In the list, they're all integers. And the output of this function would, of course, be 5 because, after all, from that list of numbers, the biggest one is 5. So why don't you take a moment? I'm going to post this up on the screen. And I'm going to just see if for the next, let's say, 2 minutes, you all can work on this problem together and see what you come up with. All right, everybody. I hope you were able to do a little bit of this on your own. I don't expect everyone to solve it before we move on. If you feel like you want to keep working, just pause the stream, and keep going. It's can be really helpful to think through it yourself, but if you want to just solve it with us together, that's totally okay too. And I see we already have a solution in the chat, so excellent work. But why don't we solve this together now, as I promised? So I pulled up a little Python notebook because it can help us run it in real time, and just show the notes as well. But we are going to check this out together. So we will start by checking. Let's just define the function first. Of course, we need to define some find max function. It's going to take in an argument here, nums. Nums is going to be that list of integers we were talking about before. In this case, it's that list that where 5 is the biggest one. And remember that we can check if the list is empty to handle that edge case, because it's possible that this list we're passing in, it could be empty. So let's say if not nums, which means that the list would be empty, that would return none. So this, we could also, or we could raise an exception. That could be possible too. Okay. And then we'll write the code now. So the way we can execute this is we'll have some variable max num, and this is going to be the maximum value in the list. So we'll start by putting that as the first number, and then we'll write a loop that says for every number in the list, if that number is bigger than the max num, then we're going to set max num to this new element. And then we'll return max num at the very end of this for loop. All right. And let's actually run this code. It's just going to define the function. But I guess I'll use a little kernel. Doesn't really matter what kernel you use, because we're actually not using any non-native Python dependencies for this. And then let's say we wrote find max, and we had our let's see, our case was 31425. Let me write that down. 31425. So if I type that in and I run the code, it should give me 5, which it does, which is great. But if we really want to see what's happening here, we could even put some print statements in. So let's just put a print statement here. Max num. I'll put a print statement here about num, and we'll put a print statement after this. And if we run it, then, okay, we can see that first the function goes to assigning that first element to the max num, which is 3. Then it checks if 3 is greater than 3. And if it is, then it would do it, but it skips that because that's, of course, the first element. So then it goes to second. Is 1 greater than 3? No. Is 4 greater than 3? Yes. So now the new max num is 4. And then is 2 greater than 4? Is 5 greater than 4? Yes. So the new max num is 5. We're done with our list. So the output is returned as 5. Okay. And so you can kind of see how this works, this function. And that's the sort of question. This is a really simple one, but this type of technical question is what you might be asked to do. So we have some solutions in the chat. If let the input be called nums, define find max. Yep, you say that the argument is some number, some list of integers. And yes, you could then just set some flag or some counter, max ELE, loop through everything and just return that eventually. So that would be great to do. All right, and then we have another solution, which is very similar. And yeah, once again, just returns that maximum value. There's a little bit of difference here because this one is checking where's the index, where's nums I, where this is bigger than max ELE. And then once you find that, you return nums I, but it's really very similar. And yeah, please check these, make sure they work with the case that we provided, and just see if you can get that to find the maximum number. But now we're going to do problem A, which is actually, I already gave away the answer accidentally, so I apologize for that, but let's go to this one. It's write a function that takes a string as input and returns the string reversed. So for example, hello as the input string would give Ole. Okay. So why don't you I'm going to give you only 1 minute for this one because this is a little bit more of a simple one. Okay, so as AXDXEXL mentioned, this is the solution. It's actually pretty straightforward in Python because there is a built-in functionality to reverse the string. And this is the kind of thing that they'll want to test you because they'll want to know, does this applicant know about the details of Python language? So they will want to see you recognize this, that it's possible to reverse the string with this simple command. And then, of course, there's some more advanced ways to do it that you might think of as well. But how would we go about solving it in Java or C? So one way you could do is you could use don't mind the X. Okay, Adele. I'll say then. Thank you, Adele. And so yes, you could do it in a different way. Maybe I'll show another way of doing it because you did ask about that. So yeah, you could use substring. So all right, let's check the code editor. We can build a solution here. So define reverse string. You could use S and return S : -1. So when we type our hello string, it gives us Ole. All right. Now there's another way to do this. I'm not exactly sure if this is the most efficient way, to be honest with you. But you could do this by just getting the string length, which is just length of S, right? And you can substring. So let's look at hello. If we take 5, actually, I guess there's not 6 letters, but 4 would be the largest. So we would start with length of S. We could have some counter, which starts at length of X, -1. Because the length of hello would be 5, I think, if you were to check that. Yeah. And then, you could have some result, and it's already ChatGPT is already coding it up for me. Well, I can't even think for it myself. But yeah, you would basically then, every time while this counter is greater than 0, you're going to substring s and add that onto the result, and then you're going to subtract 1 from the counter. And this would work for any language, including Python, including Java. And so, yeah, you get that. So you could use this method for any language, really. Yeah, but don't count on having a Copilot with you at your interview. I'm not sure. I probably should have turned off Copilot for this, but yeah, a two-pointers approach could be too. Yeah, there's many ways to solve it. So definitely, remember that there's many unique ways, but yeah. Okay, yeah, this is interesting too. There might be some other way to do it with evens and, yeah, taking advantage of the midpoint of the string, I guess. That would be cool too, to reflect the string. I like that idea. Okay, so now we're going to do the last example. So let's see, we're on slide 16. So this one's kind of another maybe about as difficult as B. After we're done with this one, I did get a question from, I forget who gave me this question. Oh, yes. Quatra said, can you use this example to explain how it fits well into prep? So that's a great question. We're actually going to do a prep problem soon. So these are just some warm-ups to get you thinking about algorithms, get you thinking a little bit about coding, and then we're actually going to solve one with prep. Yeah, let's just warm up on a few of these first. So here's problem C, and I'll give you about 2 minutes to think about this one too. Maybe 3 minutes to give a little extra time. All right, everybody. So we have some great ideas in the chat for how to solve this problem. One of them being Adele's one. So it's if you define this function valid palindrome and great job checking if this is an empty string, because of course empty string will not be a palindrome. And so you handle that case. Excellent work. And then if it is not a if it is not an empty string, then checking that going through each of the indexes to validate if it's sort of a mirror image of the other, scanning from the opposite direction to see if they match. And then you have some return statements to get you out of your loop once you discover that it is or is not a palindrome. So excellent work on that code. Good job. And then Shravaish has iterate through half the array and check if this is condition it holds true. String I equals string n minus 1 minus I. I like that actually because it might save you some time. That might actually be quite fast because you're only having to check half the array instead of the whole array. So that's really great. And yeah, they're using some more data structures lingo here, Super Yoda. We could use a stack push in each letter and then pop each letter, forming a new string, and compare the original and new string. Yes, we could do that. And actually, that would be a really neat implementation of this. So good job. Okay. Oh, Quattro actually has the same solution that I do. So maybe we'll now go and actually do the solution out together, and check that one. So what I have is the following. So I wrote an is palindrome, and some argument s would be the string. And then you could return the following condition. So s double double equals, which means s is the conditional value of a string, and its reverse, are they equal, conditionally equal? And if they are, then of course it's a palindrome, and if not, they're not. And you could include this other thing that Quattro included, which I also kind of included, which is that you could replace all spaces with empty strings. Essentially, you could delete all of the string spaces, and you could also have lowercase, a dot lower function method. And when you call the dot lower method on a string, it removes all the capital letters. So think about it this way. If I had a palindrome that was somebody's name, so Hannah is actually somebody's name, and you can basically use that as a palindrome. But think about it this way too. The reverse is going to look like this. So you're going to have Hannah on the one hand and Hannah on the other hand. Those strings are not going to be equal. Okay, so if you want to consider that to be a palindrome, it's up to you, I suppose. When you are presenting this problem to the interviewer, you want to tell them, okay, I'm going to consider this to be a palindrome. Because if I don't consider this to be a palindrome, then I don't need to have this extra case handling here. So it makes me want to do that extra thing. Yeah, exactly. In an interview, those types of constraints should be discussed with the interviewer. Exactly. So that's part of the prep method. And I know some people wanted to see the prep method in action. So this is a little taste of that, but we will actually get further into that in the future. So excellent job, everybody, on that one. And so now we're going to look at some coding best practices and some live problem solving. We're going to talk about what to do, and then we'll actually give an example. Yeah, so thinking of edge cases, that's a great question. We'll talk about that actually before we get into this next section. Thinking up edge cases, let's see. You want to imagine. So what I typically will do is look at the data type of these things. So, for example, in this case, we're looking at string, and what are some of the fundamentals of string? String has a length, okay? The length could be 0, right? And that's empty string. So we could think about empty string as a one edge case. Another thing that string has is it has these cases. So you could have uppercase, lowercase. That's sort of unique, right? So why don't we think about that as, and we can operate on that. We can do lowercase, uppercase for the whole string, camel case, right? So thinking about some of that stuff. And I think if you think more about the data types that you're working with, you might end up coming up with some edge cases. Honestly, the best way is probably just to get a lot of practice with these because they often tend to be the same. And when you have those edge cases appearing over and over again in problems, you're going to instinctively reach for them when you end up taking the interview. Yeah, and then Hamzatul says, I think some interviews may not accept the use of built-in functions. Yeah, so that's another thing. If you have an interviewer ask you, hey, I'd rather you not use this : (-1, that's what we did before. We actually had to come up with our own way of checking, of reversing a string. So could you think of a way to replace the .lower function, for example? That might be something you may need to actually do, or the .replace method. The interviewer might say, hey, I know we have .replace, but could you actually come up with that on your own? Tell me, about .replace. So that could be really, important to have. And here's another few. Not much of an edge case, but some solutions may fail when tested using odd length strings. Yep, that is actually a really good edge case example there. So that's something to think about too. Great point. You could use ASCII for some of these questions for sure. But yeah, so why don't we move on then, because we want to have some practice on using the prep method, and I want to dive into some of these coding best practices because I want you to know what's important to the interviewer, what's the interviewer going to care about when you're writing your code, what they're going to notice. One of the things is clean code principles. These are huge. So we want to see that your variable names are meaningful, that you're not just typing X to H, version 2. That's not going to be a very meaningful variable name in almost any context. We want to see you using modular functions. So modular function means that the function is doing the bare minimum of 1 unit of utility, okay? So in other words, we don't want to see a function that is like, write user report January, and then another function that's write user report December, and then another function that's get user report December. We would love to see maybe just one function, user report, and then inside of user report, there could be some more further breakdown where there's one get a user report. one, write a user report or set a user report. And then those could be generalized so that they could work with any month. So that's what we mean by modular functions is, okay, not only do functions have, a very simple structure, but also a very generalized structure so that they can be applied in many contexts. So we don't have to write 6 different functions. We can just write 2 different functions. And comments and documentation are really important too. So we want to see you explaining your work. And the reason for that is actually so that other people can use your code and so that you can use your code when you go back and rely on it again months later. Remember that, in reality, you may return to codes that you wrote 6 months ago and not actually know what you did if you don't comment it well. And that goes also to consistent formatting, readability of your code. So that's really important stuff. Okay. Handling edge cases and optimizations. So we thought about this a little bit before with the edge case example. We want to always be considering null or empty inputs. And we talked a lot about edge cases actually. Then there's the optimization. So think about a time and space complexity. How will your answer change over time? If the program has to run with a huge input, how much time is it going to take, right? And once you get a working solution, how can you optimize for that? And by optimize, I mean making the code as fast as possible. And you could also think about generalizing the code, which makes it more simple. So that would be really useful best practice. And now we're going to do medium difficulty problem, which is called two-sum. And so two-sum, I'll give you the description here. It's given an array of integers, nums, and an integer target. Return indices of the two numbers such that they add up to the target. So if you're asking me, hey, that sounds like a riddle, what do you mean? I'll give you the example below. So in the input, let's say we gave a list nums, which is the following 4 integers, 2, 7, 11, and 15. And I gave a target, which is 9. Okay. The output is 0, 1. And the reason is because the first element of this list, which is the 0 indexed element, is 2. And the second element of this list, which is the 1 indexed element, is 7. And so together, those two numbers means 9 when you add them. So that's what we want. We want a function that works for this. So I want you to try this first. And while you're trying it, maybe in the chat, you could give me some prep like comments. So for example, you could say, I would want to know this or that to solve the problem. And I would want to clarify this or test that. So anyway, yes, if you want to give me some prep-like notes in the comments, that's fine. I'm going to actually go through this with the prep method afterwards and show you all. So yeah, why don't we spend actually a little longer with this one? Maybe we'll spend about 5 minutes with this one because I really want you all to have some time with it. So why don't we go ahead and we'll use 5 minutes for that one. Okay, just wanted to pop back in because I saw Shravish's comment. Will the input array be sorted? Good question. I think that's actually one of the prep because you're asking about the problem, and you're actually also asking about requirements because are we requiring the input to be sorted? It is sorted in this context, but actually, let's say it doesn't have to be sorted. So there's no requirement. All right, everybody. Looks like we have some attempts in the chat, which is really great. Even some clarifying questions. And some people who've actually done this problem before. Yeah, it's definitely like on Leak Code and in textbooks and things like that. So why don't we, move on to the prep method and applying that? So I'll show you. So if you're faced with this problem, remember the first part of prep is that you are going to want to do problem understanding. So given an array of integers and an integer target, return the indices of the two numbers such that they add up to the target. So, you might want to say, yeah, so we do need to find these two numbers in the array that are going to add up to the target value. And so we need to return their indices, not the numbers, but the indices. And just by even thinking through these things and talking aloud and just saying like what the problem is, that's going to tell the interviewer that you understand what the assignment is, right? Because you want to actually show that you have that understanding. And you're not just reading the problem verbatim and then staring into space. Because they might think then, wow, does this person even really understand what's happening? Do I need to make it a little bit more clear to them so that we can move on with the interview and push them into the code? So that can be really good. And then R would be requirements clarification. So this is something more like Shrevesh's question, will the array be sorted? Are there any constraints on the numbers? Could they be negative numbers? Is there exactly one solution, or could there be multiple solutions? Can the same element be used twice? So could it be 3 and 3 to make 6, for example? Those are questions that are requirements clarification. And then we would go on to examples and test cases. So, okay, here's the example that the textbook gives us, or that the slides give us in this case. Given the 2, 7, 11, 15 list and a target of 9, the output should be 0 and 1 because 2 plus 7 equals 9. And what if the numbers are 3 and 3 and the target is 6? Well, then the output should be 0, 1, right? Those would be the two indices. That would give us 6. And here's an edge case, all right? Nums equals 1. That's only one number. The problem, meanwhile, asks us for the indices of the two numbers. So in this case, it should return none or an empty list or some kind of indicator that something has gone wrong, essentially, with our function. And I think there's one last one, which is pseudocode and implementation. I actually have some notes here. It's really similar to some of the suggestions from Abhinav and some brute force solution from Shrivesh and Axel here. So why don't we actually try and solve this problem using a hash map? We're going to store the numbers that we've seen so far. And as we go through the list, if we find that the complement exists in the map, meaning the complement would be the target minus the current number, then we've actually found a pair that works. If not, we'll add that current number to the map and just keep going. So why don't we try and implement this in code? All right, we have our old codes here. And of course, in the real interview where you're doing some kind of live coding, you might actually have to do some of these things all at once. So, you wouldn't be like doing P first. I mean, you would, but, you might go back to P a little bit and say, oh, let me restate this problem just so I'm sure I know it. Or, I just thought of a new requirement as I've been coding this up, right? So that could be possible. And so let's code this up. So we have toSum, which is the name, which we're going to call the name of the function. And we're going to have two arguments, which are nums and target, excuse me. And it looks like someone has a solution already from Copilot, but I wanted to do it the way with this hash map. So I'm going to make a map with this empty curly brace dictionary object. And for every index and every number in the nums list, let's actually calculate the complement, okay? which is target minus num, which is going to tell us, like, what would this number need to be if it were to add up to the target? Because if we add num to both sides, that would actually just be really obvious that, the complement plus the num would be the target. So, is that going to actually help us find the complement? And so we're going to return the num map complement and the index. Oh, excuse me. I think I messed this up. I want to say if the complement is in the num map, then we will return we'll just do the solution. But if it's not, that means we need to basically add it to there. So we'll add the number at its current index, so that we just added one more number to that dictionary up here. And over time, eventually, this complement is going to actually exist in the num map, and that's when we'll know that we're done, because we'll have the index for both of the numbers that satisfy adding them together being target. Okay, and then we'll return none. So, and then in this case, with this function here, you notice that as soon as we find a matching pair, we exit. So I could go back to requirements clarification and say, all right, remember this requirements clarification, we said, is there exactly one solution or could there be multiple? We're actually going to have one solution every time, even though there might be more than two numbers that add up to the target. We'll always have one solution because we'll just exit as soon as we find that complement. And as far as the same element being used twice, no, it can't happen, because if you look at the code that I've written up here, once you hit that first number, you're actually going to iterate and go to the next number in the list. So you need to have two. You can't use the same one twice. So that's how I've coded it up. But you could code it up in a different way and specify your requirements differently and say, this is the effect of doing it this way or that way. So yeah, there's a great example. And if anyone has, it seemed like we had a few alternatives in the chat, which were great to see. So why don't we now go on to a little break in a Q&A, and we'll take a short break now while I answer some questions. Feel free to grab some water, stretch, ask any questions you might have about technical interviews, the fellowship program, hacking, whatever you want to ask about. But yeah, this is really, I feel like this has been a really good session. I can tell that people are interested in solving these problems, and we have some really some great feedback from all of you. Okay, so Axel says, is it better to code it in one go in the interview instead of alt-tabbing? So I guess this is going to depend on the interviewer's preferences. So I wouldn't want to give you one answer that will work for everyone. But what I would say is try to do it in the way that's going to work best for you, because ultimately that's going to showcase your abilities best. So I would probably try to code as much as I can until I need to look at something. I want to check my work again, and then I would go back. I wouldn't feel too bad about not having a linear thought process. In reality, almost no one has like this linear thought process where they think of all of the conditions that they would need, and then they write the test cases, and then they write the general form. Most people go back and forth, but just try to hit all of these 4 points. And I think that will honestly be the most important thing to most of the interviewers. But that's a really good question. And what are some of the questions that we should expect in the MLH technical interview? That's a really good question too. So it's going to depend on your interviewer, but when I interview folks, I ask them about their project. Actually, that's not going to depend. Everybody's going to ask you about your project. I ask you things like, you know, what aspects of the project did you work on if it was a group project? Can you tell me more detail about why you chose to use this framework for the project? What is line 30 doing in the code? How would the code be different if you wrote it in this way? Right? Those are the kinds of questions. So it's very relevant to your particular code project and the language that it's written in. But that being said, other interviewers might have a slightly different approach, but they will pretty much do the same. Yeah, so thank you for those questions, everybody. And if you have more, just send them along in the chat. But I definitely want to keep going because we have some behavioral questions and soft skills to talk about. So, behavioral questions, I honestly believe, are just as important as technical ones because they help interviewers understand how you work within a team and how you might handle challenges that will inevitably come for the project, how you'll fit into the company's culture or not. And they want to really make sure they nail down these behavioral questions. So we ask them too in the MLH fellowship. But here's a few common ones, some of them that we actually ask in our own interviews. First, describe a challenging project that you worked on. How do you handle conflicts in a team? Tell me about a time that you failed and what did you learn? These don't need to be technical. You'll notice, I mean, challenging project, that could actually be like a sewing project that you did. Conflicts in a team could be a sports team. Tell me about a time you failed and what you learned. It could be, you failed an exam or something at school. A lot of these behavioral questions are not testing you on your tech knowledge. And if you are relatively new to the field, it can be great to rely on some other examples that are outside of tech that can get you a great answer to one of these common behavioral questions. So keep an eye out for those. And I have another acronym for you all. It's called the STAR method. So the STAR method is one of these acronyms that's great for a behavioral interview. So the S stands for is situation. So it's you want to describe the context in which you performed the task or faced the challenge. So, I first said this describe a challenging project you worked on. You could say, well, when I was in 11th grade, my team and I designed a catapult for a statewide catapult contest. So that would be the context. And then the task here would be explaining what you were actually responsible for. So I can say I was responsible for, designing the advertising materials so that for our catapult. And then A could be actions, so detailing those specific actions you took to address the task. So you say that involved me printing out flyers in communication with the students in the school to let them know about the catapult contest. And then results. So you could say in the end, 1,000 people showed up to our catapult contest, and we ended up winning the contest. So that would be the STAR method, and it's a great way to stay on topic and stay to the point. So, what are some examples? I'm going to give you an example here. Okay, so the example is, tell me about a time that you had to learn a new technology quickly. All right, and so here's the STAR of it. So, the situation in my previous internship, our team decided to shift from REST to GraphQL APIs. And so the task then was that I needed to get up to speed with GraphQL because I wasn't familiar with it before and contribute effectively to the project. So, first, I dedicated some hours to online courses. That's an action. And built some small projects, also an action, and collaborated with a colleague. And then within 2 weeks, I was able to contribute to the project. That's the result, right? So we have all the elements of the star response here. And then here I have a mock technical interview that I want to go over. So this is, uh, I'm going to actually go through the whole thing and we will talk a little bit about it at the end. So I want you to pay attention to this mock interview, all right? So that we can talk about it at the end. So I'm going to be both of the people. So the interviewer says, "Hi, thanks for joining me today. Are you ready to get started?" And then the applicant says, "Yes, absolutely." So the interviewer says, "Great. Could you write a function that checks if a number is prime?" And the applicant says, "Sure. So to confirm, you want a function that returns true if the number is prime and false if it's not?" And then the interviewer says, "Exactly." So that's the first page here, all right, of the story. And the applicant then says, "Okay, then I'll start by checking if the number is less than 2, since primes are greater than 1. And then I'll check divisibility from 2 up to everything but the number itself." All right, so they have this function they've written, they've scripted it out. Def is underscore prime for I in range 2, comma n minus 1. If the n modulo I is equal to 0, then return false. And if not, return true. So the interviewer asks, "Can you think of any optimizations for your solution? Can anyone here think of any optimizations for this solution?" Remember, this is a function that's checking if a number is prime. It's kind of a niche topic, actually. So if you don't know it right off the top of your head, how to optimize this, don't feel bad about that. It's very kind of a number theory topic, but just an example. This is just an example. All right, I'm not seeing any answers, so I'm just going to give away the answer. But the applicant then says, "Oh, yeah, that's right. Instead of checking up to n minus 1, I can actually check up to the square root of n to reduce the number of iterations." So then the interviewer says, "Good thinking. What about the edge cases?" And it says, "Well, I guess I should also handle negative numbers, 0 and 1, since they're not prime numbers." And so then this is the final code that the applicant writes. All right. So yeah, maybe some people don't know that, but actually to check if a number is prime, you only need to check up to the square root of the number. Um, yeah, but it kind of makes sense, right? Because you might, actually, it's kind of a complicated proof. So I won't get into that, but there is that to contend with the prime checker. Um, all right. So I want to now ask you all, based on this conversation, how do you think the applicant performed? Remember, you can rewind if you need to. But what did they do well? What could be improved? I'm going to give you a minute to think about this. Yeah, just respond. All right. So I did give some time for you all to think about this, and indeed, you did give some great comments. So I want to highlight Alquatra's comment first, which is a positive one, and I totally agree with this one. He did well. Yeah, I think he did great in terms of correctly identifying the questions and initially asking clarifying questions. So that was really good. You can see in the beginning, just confirming that you want a function that returns true if the number is prime and false otherwise. This is prep. This is problem understanding or prompt understanding. So then in the next bit, explaining what's happening. And there is actually a little bit of a prompting here of edge cases. So the interviewer asks about edge cases. I personally would want to have the applicant bring up edge cases, bring up that would be part of requirements clarification. Just to clarify, do I need to handle negative numbers or 0 or 1, since those are not prime numbers, right? But otherwise, really good job. And that is what actually Srivesh suggested. So I do agree with that. And then, yeah, he did good overall. I mean, there's not much else I thought could be improved, other than obviously getting this optimization correct the first time. But you can't really get everything right the first time. And like I said, that's not even the most important part. That's like third in the list of stuff to improve here. So yeah. Okay. So now the next slide I have is about the conversation strengths. Yeah, so we mentioned those all, and then areas of improvement. There's a few others that I have here, but again, there's not a lot more to do. Yeah, of course, discussing time complexity, space complexity. I love how in Shravaish, you actually wrote in your answer to the two sum that you stated the space and time complexity. And if you can do that, that's really great because it shows you're thinking about the algorithm actually about in terms of efficiency, which is really important. So if you can do that, try it. And actually, I have a workshop where we will dive into space and time complexity coming up in this Global Hack Week. But yeah, stay tuned for that a little bit if you're interested. But yeah, we'll talk now a little bit about common mistakes and how to avoid them. So here's some common mistakes. Not asking clarifying questions, right? We want to start that out at the beginning before we even get started by coding. And even before we plan out our solution. And then number 2 is rushing into coding without planning. This is what I was talking about before. Start coding as far as you can, but don't go too far without reflecting back on what you're doing. And then poor communication. This could be where, you might not be really explaining what you're doing or using prompt understanding to demonstrate to the interviewer that you know what's happening, because you might not get that first answer on the first try. Ignoring edge cases, which we saw in our example, and not testing the code. So actually, that's another thing that the interviewer did not do, is test the code. We want to test with a few primes, and make sure that the code works. And there's overcoming interview nerves too. So to do this, honestly, I have found in my experience as an interviewer is that you really want to practice mock interviews. And that could be by yourself in your room with a camera recorder, or it could be with your friends. Just get as many practices in as possible so that when you hit that real interview, it doesn't feel any different. And familiarizing yourself with some common questions is another idea that is super useful. And getting some pre-interview routine. Every day before the interview, I wear these clothes to the interview. That's my interview suit or whatever it is. Interview top suit if you're doing a remote. Sometimes people only get dressed up, in the top for this camera, wear sweatpants in the bottom or something. But whatever you do, get that routine down. And remember, it's okay to take a moment to think. It's not like you are, even ChatGPT takes time to think. Okay. So just take that moment to organize your thoughts. And some final tips. Remember, we used all these things. This is just my little cheat sheet to have you remember those acronyms and have them on one page: PrEP, method, and STAR. So, and then here's some resources to practice. I definitely recommend LeetCode, HackerRank, CodeSignal, Cracking the Coding Interview, and some of these other things. So, audience, what was your biggest takeaway from today's workshop? I want to know. What did you think was the most valuable thing? John Zalan says communication. I totally agree. Communication cannot be emphasized enough. And yes, it's not all about finding the solution. And Abhinav and as well as Shivaish both said the PrEP method. Yeah, the PrEP method is great. It's really kind of like the equivalent of STAR, but for technical interviews. So when you are thinking in that way is going to be so useful for you. So yeah, and knowing what interviews look for. You've never been in one. So if you have never been in an interview, I highly recommend to apply to the fellowship program because, once you get a working application together, and you may have to actually apply for a few batches before you make it to the interview stage. But once you get to that interview stage, you can practice in that format and gain some confidence. And it's free as well. So I highly recommend just applying for things, and not just the fellowship, but really anything. Apply for stuff, and eventually you'll get that interview and you'll get that practice. And it'll make you more confident and more prepared. Then Super Yoda 1, practice makes you perfect. Totally true. That's true of anything. And don't be afraid of rejection. If you get rejected from that interview, take that as, okay, I want to improve on the next time, right? What can I do better next time? And eventually you won't even be afraid of being rejected because you will just have done this so many times. And then, of course, when you least expect it, you're going to get that offer. So that's just how life works, in my opinion. And develop an algorithmic thinking approach. Yeah, that's true too. Do not get focused overly too much on one language, because languages are always changing and packages are always changing. You will work for a company with a code base that's totally different. So you don't want to rely on a specific framework of thinking. You want to be able to generalize to algorithm level, to abstract level. And yeah, confidence in being prepared. So I think we all have a lot to, you know, to take away from these things. Everybody has these strengths in some of these things, and everybody has things to work on. So I hope that this session has been useful to you. But let's take a quick recap. Understand technical interviews, get some of those problem solving strategies, learn about how important is communication, behavioral, and some of these common pitfalls. All right. But yeah, if anybody has any questions in the last minute, we'll do a few minutes of Q&A, and that will be it. I'm gonna, while I'm waiting for some questions, if there are any, I'm gonna actually check our next workshop. I'm trying to be a little bit better this time. I think we are actually all trying to be better about letting you know what's coming up next, because there is so much great content at Global Hack Week. It's actually going to be a stream with UT. In 8 hours, there will be UT stream, which is going to be called Mobile App Development with React Native and Expo 1. So that's going to be, I'll send you the check-in link so you can download that. I think we send you a calendar invite there. But this is UT's next stream. And I'll also give you a sort of a heads up that I will be having a stream tomorrow on data structures and algorithms, which is going to be sort of similar content to what we covered today, but there will not be too much overlap. So if you liked this stream, you like thinking about this stuff, you want to get more practice with data structures, algorithms, let's meet up tomorrow or watch the recording, and it could give you some of that extra practice. Yeah, so Axel says, is CTCI still relevant? Are there better books? I guess I am not super familiar with the most recent books, but it's certainly one of the books that I use to prepare. And it cannot hurt to read that. A lot of these topics about data structures and algorithms, and they're gonna just still stand the test of time. These basic building blocks don't change too much over the years, I've noticed. I've noticed as a developer, you have seen a lot of advancements in fields, machine learning, for example. Even React was such a groundbreaking thing, changed everything about developing on web. But these data structures and algorithms things, they don't change at the same speed. So I would say read it, but also read newer things too. Yeah. So just to answer your question, Axel, I rely on, yes, university courses. I even in university took a number theory course in math department. So if you have a math class as well, you can even take math classes in number theory and combinatorics and things like that. And I've also watched online courses. I just recommend get as much information, high quality information from as many sources as possible. Read old things, read new things, read, whatever you can. Because it really is going to help you to just have that foundation and that building block. Because when you get to the interview itself, it might be quite different than anything you've prepared for. So what you're going to want to do in that case is, just have those foundations to rely on, because those parts of the interview will still be the same, so that you can focus on devoting your mental energy to things you haven't seen before. And hopefully that's not too many things if you study a lot of different sources. But yeah, so thank you everybody. And those next workshops I mentioned in the chat, UTs is the next one. And then my data structures and algorithms class will be tomorrow. So yeah, it was great to have you all on the stream. And thank you once again. Take care, everybody.